Hello, my name is Kamil Çoban, and this is my um, machine learning homework 2. I'm gonna presenting about it. So let's get started. Our topic is the binary logistic regression with the given cost function of this and loss function of this. Okay, I'm starting with the defining the sigmoid function, which is um, the this given like this. After that, I actually calculated the definition of mu function, let which is given like this and given like that, like here. Okay, the last function, which is the difference from the y predict and given y. So we need to minimize this loss function because loss function because cost function is the mean of the sum of the loss functions. And as you can see, it's a loss function, sum of all of it, and divide of the number of the loss functions. Okay, as you can see, the misclassification error. Actually, misclassification error is the point that, as you can see, there is a point away from the another classifications and the decision border. We need to calculate this error, which is called misclassification error. In the step function, actually, we are using the batch gradient descent algorithm in our binary logistic regression. Definition of the step function is the every single step of our complete binary logistic regressions gradient batch algorithm. Okay, gradient descent algorithm. What gradient descent algorithm does is it's repeating until convergence the derivations of the gradients W and bias, which are parameters of our model. In train function, we are giving our train and test data, and there's nothing to say much about it. In every iteration and number of batches, I just take a step one by one to decreasing the W, which is the derivation of the W. As you can see here, let me show that gradient J bias is the right here. Gradient J weight is right here. Actually, it can be calculated like this also. Okay, let's talk about why we need to derive weight and bias, our parameters. We need to keep cost and loss functions are minimum. We need to minimize those functions because um, the occurrence of our prediction is related our how minimum how how minimum our cost and loss functions. We need to minimize the cost function, uh, which we are doing with the minimizing the loss function. To minimize the cost function, um, we need to derive the weight, because whenever we derive the weight W, we are getting closer to local min, and it is approved for the bias also. Let me show that in another example. Let's we have an axes are like this. I know it's not the logistic regressions, but I can show the gradient descent algorithm of it. Okay, let me see. Let's take an W right here. In every time we derive the W and assign to itself, we are taking a little step. Again, one more. Again, one more. Again, one more. Every time we take the step, we are closing to local minimum, which is right here. Actually, this derive, which is the slope of the point. It is calculated like this or this. These two are the same actually. Okay, I think I'm having a. I need to be in a rush, so probably I will cut the presentation right here. So the main thing is the clear. I hope the main thing is clear. We need to derive our parameters to getting getting a little or less losses to little or less cost function. Okay. Now I'm gonna run the code I need you to see this code. As you can see in train data, in train method, you can see every iteration and losses and train and test losses. This is not important I import these to solve a bug. As you can see, there are two plots, as you can see. Okay, I think I need to show the test run. I run the test, but I want to run again, as you can see. I couldn't figure it out how these two methods have the failure, but I'm quite sure that these are calculated like this. Thanks for watching.